right. So welcome everyone. Let me share a screen. All right. This is on screen, right?
Yeah.
Amazing. Let me
Okay.
just get
Hmm.
organized a little bit. Okay,
Yeah.
good. So thank you everyone for joining again. Today we're talking about something interesting about thinking and how we call it skill that everyone forgot. Now, as usual, that we start with a quote. This one is from one of the Greek philosophers. The mind is not a vessel to be filled, but a fire to be kindled. And let's see why is it important for us. Now, historically, about thinking, we can see that the thinking was developed as a not as a result of us being born with it. We never been born with a natural ability to think creatively, right? Or think in general. We born with reflexes. But it's actually been something that's been taught over the years and over the generations, right? Why it's been developed? It's been developed for us to even survive. It's starting from the early human beings where they needed to survive in their cave, all the way to the industrial and agriculture and any other revolutions after that. We needed the thinking to survive, and the thinking was developed as a mean of survival. Right. So any advancement in human development of thinking is happening only under one condition, under challenging circumstances. Right. If we're not challenging ourselves, if we're in the comfort zone, there is no development in that space at all. And we'll see why in a moment. Now, lately in the last few decades, we see a little bit of a paradox, right? We have plenty of tools out there that we can use, but these allow us, in a way, to think less. For example, we have a huge amount of
Yeah.
information that these tools provide us, right? But we already long forgot, or many of us long forgot, why do we need that information? How can we even use it, right? All of these analytical tools that we see out there. We have a lot of automation in the world, but people who build it are not around anymore, or they even themselves even forgot why the automation is there, how does it work, or anything related to that. And today, of course, we have AI. And in AI, we basically outsourcing the ownership of thought to AI in many cases. So we reducing the ownership of our own ability to think. No, so basically we can conclude it as we used to think to survive. Then the Google and internet came along. We were able to search, or even in the library, we were able to search for that information, potentially to solve problems. And now the perception is that we can simply ask, right? We're not even many times not even checking the truthfulness of that information. We just ask. Now, so since we're talking about the AI, there's two different goals how we can utilize AI. One is, interestingly enough, for not thinking, and another one for thinking, which is interest. It sounds interesting, but when we decide not to think and use the AI in order to not to think, why do we do that? It's easy. We basically ask AI to make the decision for us, to potentially solve the problem for us, to create something for us. And many times happens specifically in software engineering, right? We outsource the thinking to the machine. Technically, it would be exactly the same thing if we outsource the thinking to a neighbor, right? From our perspective. At the end of the day, we're not forcing ourselves to think. We're definitely in the comfort in our comfort zone, and our comfort zone even increases, but our capability decrease because over time, if we don't need to think, why would we develop ourselves? So we intellectually degrade. Now,
Yeah.
if we're
Can I make a
choosing,
question about AI?
of course.
Okay. Been studying AI quite a bit. And to make AI work, you have to have these huge data centers that require a lot of electricity and a lot of
Mhm,
water. And I'm seeing
mhm.
communities now resist having that data center put close to them. like in the older days, they resist having a nuclear power plant put close to them. I'm
Right.
also seeing that when you say use AI, it's not a general everything, but different people develop different parts of AI. So you have to ask
Hmm.
yourself, which AI database am I asking?
Yeah.
I can ask your
Yeah.
database, or I can ask ChatGPT, or I can ask somebody like that. So,
Of course.
yeah, I agree that using AI leads to intellectual degradation, but it also has to increase your intellect to know what you're using and what you should expect to get as results from using it. Otherwise, you go down the wrong road. My,
Exactly.
my, my
Exactly.
own soapbox.
And that's exactly what we wanted to emphasize, right? But then, and again, we're not by any stretch of imagination against using AI. Using AI is an amazing tool. The question is how you use it and what you're using. And also, as an example, what you mentioned, it's a different database for AI, or in the world of AI, it's called different models, right? So different models trained for specific things. Some of them trained for software engineering, some of them trained for other things, for writing, for example, right? Or there is a general AI like ChatGPT and Gemini and things like that, which are much shallower, but they have this wider knowledge or wider statistical data, right? But at the end of the day, the point that I'm trying to make in this particular slide that we can choose to use AI just because we want to make our lives easy, right? And that's okay, but there are circumstances as a result of that. Or we can use AI to actually help us think and become better. At that point, we can make AI AI becomes, or any other machinery, in fact, specifically AI, becomes a companion, where, as an example, it can search for the huge amount of information, it can find data, it can organize it in data, it can automate things, right? It's things that we're doing pretty well ourselves, but it just takes time. And then we focusing on something much more important, like analyzing this thing, modeling, the thinking, the innovation itself. And that's what officially called intelligence amplification, right? Where the thinking becomes stronger, not weaker, over time. Again, it's a choice of how we're using AI. So AI, how we see it, it's an additional degree of freedom. So basically, it's not really changing our world around us unless, but how the world changes around us as a result of using AI depends on how we decide to use it. Okay. Now, we too, as human beings or as a world, we coexist in two different conditions, in comfort zone or in challenging conditions. Now, in comfort zone, again, it's okay to be in comfort zone, but basically, at that point, there is no problems to solve. There is no pressure. Uh, there's no urgency. We be basically defaulting to status quo, and that's our goal becomes the status quo. We use AI, and that's okay to avoid thinking, to stay in that comfort zone. But as a result, our skills again decline, right? Or when we're challenging ourselves, or if our environment challenges us as human beings, as society in general, then what it means we have to solve the problems. The constraints themselves become very visible, right? The pressure increases. The pressure of our us being able to solve these problems increase because otherwise we basically gonna collapse. We're not gonna survive if we're not gonna solve these problems. The thinking develops as a result of that pressure. And yes, we can use AI still, of course, like we said before, but we should use it to develop ourselves and to improve our thinking process and not outsource the thinking process, right? Now,
You say that AI could be an alternative to brainstorming. Could I think of it that way?
E- so, in a way, right? Because what brainstorming is, and I mean unstructured brainstorming,
Right.
and we've seen it in the last few years when we were digging into that. Brainstorming, again, unstructured brainstorming. What it means that people trying to find solutions or ideas out of their memory, out of their whatever they have. Very rarely finding something extremely creative, especially in the complexity of the systems today, right? AI is actually pretty good at that. It can dig through the existing information that exists out there and bring you something that's statistically matching the best your use case. So yes, you can claim that brainstorming is actually a good candidate for AI, right?
Okay. Yeah.
But not necessarily for coming up with something completely innovative and creative and completely new, right? So just to summarize, we have to get ourselves thinking. How do we make ourselves think? Uh, First of all, well, we basically solve problems. We have to make ourselves solve problems because the only way how we can solve problems is through thinking. No tools out there will help us. Now, again, I'm coming back to AI. AI can help us with automating things or being trained to do some solve some trivial problems, which is fine, like automation. So we can automate using AI things that we're doing best ourselves anyways. We just don't want to spend the time for that and free our mind to something bigger, right? But we still need to encourage the thinking. How do we do that? We first of all we need to reward the thinking because we've seen in the last few years that in many companies the thinking is not valuable anymore in the companies, right? Constructive friction inside the organizations or across people. That's very important as well. Challenges with complex problem solving and so on. At the end of the day, we need to be out of the comfort zone to make ourselves think.
Yeah.
Okay? I'll pause here before I switch to the platform if you have any questions.
This is what you just said is very true, and it's a very powerful incentive against thinking, right? Because we know. I mean, I see these in students sometimes. Uh, Getting into the problem to the degree that you get stuck is
Hmm.
very uncomfortable. You want to
Of course.
avoid it, and so there's a logic. It's a powerful truth, which also explains kind of why organizations don't think because it's very uncomfortable.
It's
Yeah,
very uncomfortable. And if you find solutions, or how we love to call it, patches, without the thinking, it means it's cheap, it means it's easy, and so on. And it's very visible for a very short period of time, but
yeah,
long
and
term,
someone else's responsibility, perhaps. That's even, yeah, yeah, yeah,
exactly,
yeah. But you
exactly.
get
So
patches, exactly.
Okay.
exactly.
In my industry, I don't have to worry about thinking about problems. I have problems coming in faster than I can solve them, and I'm trying to get them
Yeah,
arranged and managed, and I don't have time to think. And then I said to
mm,
myself, David, this is foolish. You just need to stop and do each problem as it comes in, one at a time, and go through a good thinking process. And that way, in the long run, you get
true.
better
Yeah,
answers quicker.
Of course.
yeah,
And I can see AI might could help me that way in solving the trivial problems and leave me more time to think about the more
yeah.
complicated problems.
Of course. Now, also, don't forget
Hmm.
that the way that we always trying to promote it, the fact that the problem exists, this inconvenience of having a problem exist, it means it's an opportunity for us, for the company, for the world, for doesn't matter. It's an opportunity for us to innovate, right? So
Yeah,
it's a good thing that we have the problems because we developing ourselves, we developing whatever the world we live in. So it's a good thing to have the problem to solve, but we need to allow us ourselves to actually solve it and not to find another cheap patch.
Another thing that I might mention is an adjunct to AI is I like to watch YouTube, and it has how people have solved problems. I saw the other night how soybean farmers can work with asphalt people to make a better product for roads. And
Mhm.
sometimes just being exposed to the thinking of others helps you think creatively. So don't
Of
forget
course.
to
Totally.
listen to others.
Of course.
Yeah.
пшеницы и нашел мандрагоры в поле и принес их Лее, матери своей. И Рахель сказала Лее,
Can I
дай
just
мне
ask to mute
мандрагоров
from
сына
people?
твоего. Но та сказала ей, мало тебе забрать мужа моего.
Okay, sorry about that. So let me at this point switch to the platform and basically demo what we mean by intelligence amplification and how we can leverage different toolings that we have in the platform itself to make that happen. Why is it not sharing? Okay. You see my screen, right?
Yeah.
Okay, great. So let's just simply start creating project, right? A project in our platform, it's basically a collection of, it's basically a representation of of a thought process to solve a particular problem, right? That's really what it is. And even starting from these very, very initial stages of creating a project, it's we're already forcing people to think, and in this case, even choose an industry, right? There's different ways we can do it. We can either choose from whatever we have, but that's not interesting, right? Again, we're talking about AI, but we can say, we make microchips and ask
Yeah.
a little bit help from AI. And then, okay, great. It gives us the semiconductors manufacturing. Now, whether it fits us or not, that's a different story. And again, we can treat it as a suggestion. How do we take it further? It's up to us, right? We are the decision makers, not anybody else. Same here, you don't have to, sift through thousands of different departments. You can just say develop new products, and kind of the same process. We continue with this process of going forward and so on. What's our goal? Let's say reduce costs or improve yield, right? So we can do that. Now, in our case, the project that we want to create, that's one of the projects that we already showcased. That's one of the case studies that we're using a few times in the demo, but again, in here, we wanted to show something else. So repeating a project is fine. And it's particles are left on, or what, wafer cleaning issues. It's just the title of the project, right? So great. Now, what this gives us is, first of all, an overview of a project. Now, the overview of a project is usually something that nobody does and nobody likes to do because it's this mechanical work, and people usually know what their system is about and what their problem space is about. And at best, they have a one-liner somewhere or an email somewhere, and that's about it, right? But what we're forcing people to do is actually describe it in very small details about what is the system is about, what the problem you're trying to solve, why you're trying to solve it, what the failures are. So everything that we know about the project. And AI is very helpful here because AI can basically evaluate. It cannot make any decisions, but it can evaluate and say, you know what, you did provide
Yeah.
some minimal information, but it's not enough. Interestingly enough, it's not enough not only for the AI to continue forward, it's not enough even for the human being to continue with that, right? Which is very important, especially when David, you just mentioned working in a team. It's extremely important when you're working in a team when everybody is aligned on the same information, they have the same information in mind, they have the same goal in mind. Okay. Now, what we can do instead, and of course we can continue developing that. There are some hints that we're providing. Again, it's something that we think that's important to have in the description or in the overview of a project. So we have a few things prepared. Again, some of you already seen it in the past. And if we go and reevaluate the same thing, right, we will get a completely different picture from that. It's already 80%, there is much more information. Of course, additional suggestion is needed, but it's much better. It's much better for the machine to continue forward as well as for the human being. And our focus is to make it clear for the human being. Okay, so that's basically one of the first steps in problem solving, even understand where we are. Next is, of course, problem statement. Nobody likes building a problem statement. And if you take a team of engineers out there and you say that working on the same project, they all know what the problem is that they're trying to solve. The issue is that for everyone, it's a different understanding, right? So building a problem statement is extremely important so everybody on the same page. Here too, we have a little bit of help of AI, right? It basically takes the information that we provided in the background and it describes based on its understanding and a little bit based on the common knowledge what's the current situation is of the problem that we're trying to describe, right? It's okay to use that description and it's okay to adjust it and do whatever we need if we don't agree with it. Not agreeing with AI is actually a good thing. It's the same thing as you would not agree with your neighbor or your coworker or anybody else. This is where you start the argument, right? And that's absolutely okay. AI gives a hint, it's not a solution, right? And again, it gives a hint based on what you provided already. Next, why the situation is bad, right? It doesn't give you one answer, it gives you a few options. Whether you agree with them or not, that's up to you, right? And you can rerun it again and see maybe something else comes up. But the point here that it gets your wheels turning to understand, okay, there's few options. Also understand how the tools work as well. Uh, and again, take it or leave it, argue with it, write your own. It doesn't matter. But for example, in this case, the introduction of defects post cleaning can lead to lower yield. Yeah, it is. Relying on traditional problem solving, well, that's not interesting. Removing new batch of cleaning chemistry could result in increasing operational cost. Okay, that's potentially also a disadvantage, right? So we can take both of these. Now, the next one in line, oops, the next one in line is what's the ideal final result? An ideal final result, it is coming from a PRIZ methodology. Basically, if you have a magical wand, where would you want to be today, right? Same concept here. We can ask AI, we can write ourselves. Ideally, we probably have, oh, here you go. Achieve zero defects on the Wayfair post-cleaning. All right, well, let's use that. And so on. This process continues the gaps, right? What actually prevents us from getting there? Normally, this is done by a team of people, and it's best when it's done by a team of people. And then, this is where the actual brainstorming begins, but it's a structured brainstorming. It's a structured brainstorm, which is very important. So let's take lack of innovative solution now. Depends on traditional problem solving, insufficient understanding. I like this one, right? We basically don't know why happens whatever happens, right? And then based on all of this information, we can finally build the problem statement that everybody aligns on, everybody understands. And again, a few options in here. Defects on the wafer, post-cleaning, yada yada. Uh, necessitating a deeper understanding of how slight variation of chemicals. Yeah, we can take that, right? So bottom line, the problem is not that we have particles and defects. It's the fact that we don't know why they're there. That's the important piece, right? Based on this particular problem statement. So now we completed this important piece. Sometimes it takes hours, sometimes minutes, but it is a hard piece of work. Now, next thing, where do we start? And many times you have a practitioner in the company or somebody professional in problem solving, or somebody process driving guy, some guru that will say, do this or do that, start there. Again, we were able to have AI help us with this task a little bit. And it's actually a pretty good result, right? Well, if you don't know, let's do some root cause analysis. Great. Or as a part of this root cause analysis, the process functional model can help you because this is what will allow you to understand how your own process works as well. And that will help you with the root cause analysis, right? So pretty good result. Let's start with
Thanks.
cause and effect chain. Here as well, it's important to have some level of description in the cause and effect chain. And for the sake of saving some time, we already have something prepared. A description here, if not, it's not the entire problem space, it's the actual thing that we're trying to analyze with the cause and effect chain, right? In this case, we want to analyze why defects remain in the wafer during the cleaning with chemistry and so on with some details, which is great. And now we can actually start building the diagram itself. And let's start with the actual failure, not the problem, the failure. What is the failure? Particles remain on the wafer after cleaning process. Okay, good. And we can continue with that. And guess what? AI can help here too. David, coming back to what you mentioned before, is AI good for brainstorming? This is exactly what AI does here. It brainstorms based on some statistics and some common knowledge, or based on something that happened in the past, right? So it can bring some results, observation that known from the past, which is great. Uh, but if you have very specific use case that never happened or AI doesn't know about, or you don't have enough information inside the project context, it's not going to bring, right? So, but let's take this one. Altered chemistry, wetting behavior reduces particles dislodgement. Okay, we can try it again, right? And whether we choose it or not choose it, it's really up to us. It will have the context of everything. And I will repeat it over and over again. We should fight with AI. Its decisions, it's only a suggestion, right? And that's important. For example, elevated components in chemistry, batching increased particle adhesion. Maybe, right? Subtle viscosity change in chemistry, reducing coverage on the wafer. Uh, Maybe let's take that, but I wanted to uh, change it. Um, Changes the I don't know. Let's leave it like that, and so on. So we can start building these let me do it again. These chains and understand how we do it, and understand what causes different levels and different problems. Uh, let's take this one. Either through with the help of a machine, or we can write ourselves, right? We can say uh, it, you know, what did we say there, Anatoly?
Chemistry evaporates before removal.
Chemistry evaporates too fast
Yeah.
before uh,
Defects removal, particles.
before the particles are removed, and so on, right? And then we continue next level and next level and next level. Again, we have a team of engineers who are working on it, but we also have an additional help, which basically brings huge amount of information based on common knowledge and based on the context um, of the project. Now, another tool, very useful tool that we have is, of course, 5 whys. Very similar, but it's a linear approach, and it allows us to go additional level to actually come up with potential solutions at every level, right? So we start with the same failure, same concept here. We can ask AI or we can write ourselves and continue further with that, right? Now, what I found out is quite easy, and I'm sure you guys had exactly the same experience. It's quite easy to work with somebody and talk with somebody through a problem or basically brainstorm. It's actually quite easy to do that mentally. But what if you don't have somebody around you, right? Then you can talk to a machine to a degree that can help you with that. Inadequate process parameters. Again, I won't go into the details. I'll just go and run a few of them just to show the next phase. Oops. Next phase. Of course, it takes some time because it does need to think, but we need to think too, right? We need to come up with a solution as well. Excess component, higher concentration shifts pH balance, uh, and so on. Let's do it this way. And again, once we got uh, to the dead end, let's assume for a second this is a dead end, we can also brainstorm at solutions. Again, I'll repeat it again and again. The whatever AI proposes is just statistically available out there. It doesn't mean just take it as is and this is your solution and just submit to whatever AI said, right? No, not necessarily, right? And even more important, fight with it, same as you fighting with your coworker, and so on. Now, the last but not least that I wanted to show you is actually one of our most powerful tools. It's called functional modeling. Some of you already seen that. And functional model, let me switch here to the same kind of project that we already seen in the past. And functional model, oh my God, my apologies. Functional model that it takes some time to build. We all know that. We need enough information. It takes sometimes hours, even days. And this is an example of a model that we built ourselves by hand over time. There's different variations of this model, how it might look like if we change specific processes, and so on and so forth. And of course, these things uh, will calculate the ranks, which is the functional rank and the problematic ranks. This is where the analysis that we need to do begin, right? A lot of a lot of these work is what we call a boilerplate modeling or boilerplate work that we need to get through to model the existing system, even though it's pretty well known, right? What we mentioned in the um, uh, presentation, that this is potentially one of the things that we can automate, right? So let's try it out. It's a little bit more detailed description. We can go ahead and, first of all, again, we want to validate the system. What does it mean to validate the description of a system? Is it enough for us as a human being, as well as for the machine to understand and go forward, right? We got a nice green mark in here. It still has some critical gaps in here, include like quantitative specs, the control logic, and so on. It's never going to be perfect, and that's okay, right? But it's enough for us to move forward as human beings, as well as the machine. But what we're capable of doing now, we can use the machine to build the functional model for us. Something that usually takes hours, if not more. This can now be achieved in under a minute. So let's give it some time. Here you go. Here's some model that it did build over a few seconds. Now, is it a perfect model? Not necessarily. It's mostly incomplete. It's mostly incomplete. And this is where we can start actually playing with it and start perfecting it and improving it over time, right? Now, but we already got some results. We already have this boilerplate work that we needed to do anyways and collect all of these components and put them on the page. Again, it takes hours. Map them. What does it mean? How do they interact with each other? The AI will do the best it can based on the common knowledge and based on the description that available in your own system description. It's a starting point from us. Now we can actually dig into the smaller details. We're not tired after hours of digging into that. We can now start using the brain and not just mechanical us to build the model, right? But even here, we're already getting some results of components and ranking of the components and what they mean, and so on. Okay. Now,
Oh,
I wanted to show some.
may I add
Of course.
one more
Of
comment?
course.
You have two possibilities to develop this model. First, you can add components and functions, or you can go to system description, click on system description, and start to add description, to start to describe in more details the system, and AI will correct the functional model according to what you are writing here. So you can write and correct system, or you can directly correct system.
Yeah, let's assume. I mean, we know this project. We already did it in the past, and some of you already seen it. But let's say we add a little bit of information here. We suspect, we still didn't have a proof. We suspect that the wafer is breaking. Oh, sorry, that's not a breakage. Which one is that? We suspect that the solution is flying away from the wafer too fast. Let's say it's not a evaporation problem, but it just flies away too fast, and that's it, right? If I just go ahead and rebuild this whole thing again, the model will look very, very much different because it will have a little bit more information to that, a little bit different information to that. And in here, I can say, you know what, I'll create a new version and let it do its thing, right? Same concept. It will create some sort of base draft of the model. We are the ones who need to further perfect it and improve it and so on, right? It's a completely different look and feel. And also the ranking, of course, are completely different. Now, another thing that I wanted to show you since we have a little bit of time, is we were experimenting with something more complex. Tesla Model 3. We don't know what's there. I just pulled it from an internet or probably from ChatGPT or something like that. There is an image of Tesla Model 3. Let's build a model from that. Right? Same concept. Me, as a non-professional in the field, I have no idea about the details. Let's do it. Again, it will take a few seconds, probably 20, 30 seconds to do that. But what I wanted to show you, great. All right, so it did build a model. Amazing, right? Let's look at the ranks. The ranks all nice and blue, all functional, which is probably incorrect, right? Or incomplete, rather. Central touchscreen. For some reason, this one doesn't get any functionality, even though we know 100% that it does have a lot of functionality, right? But what does it mean, functionality? It doesn't have functionality. Basically, the model decided not to connect to anything because it didn't find enough statistical data to say, this is providing this type of function. But this is where we come in. And we're saying, you know what? The passenger is the one that the touchscreen informs. Oops. The touchscreen informs. Uh, Also, the passenger controls the controls the touchscreen. And you know what? I decide that the driver is not important. I don't want a driver separately from a passenger. In my mind, driver is the passenger as well. But what else the touch screen does? It distracts, right? It distracts, and it's probably not something that we really want. And so on. So we go with this initial model and we start improving it and completing it. And now if you look at this ranking, it looks completely different, right? The chassis is the most functional. Again, based on that first draft. But because of our changes in touchscreen, in my mind, when I was working on modeling a car, I would never think about the touchscreen. Never in my life. Because in my mind, a car is an engine, wheels, chassis, doors, windshield, and so on. Never a car. Here's another example. Since David and Pankaj, I don't know if Pankaj here, and Matisse. So something that we did a few weeks ago is the modeling of a heart. Let's do the same exercise. In here, we literally just have a few pictures. Is it enough information for us human beings? Yeah, probably. Right? But apparently for the machine as well. And we can remember, Dave, that we spend a lot of time to even do this initial modeling, right? That's exactly what the problem that we were trying to solve. To do the initial work, this initial draft of the model, and then continue with the analysis from that initial draft, not from a blank state, right? So let's give it time because I want to show something very, very specific right after. Let's see.
There needs a little hourglass that turns around, shows you.
Well, there is one. There is one there. So this is interesting. So this is interesting. Again, it's largely incomplete, and we can continue working on that, and that's fine. But what if I do something else? The human heart after a heart attack.
Oh yeah, that's cool.
Right? So again, we didn't provide any information about what type of heart attack, what happened to the heart, where did it happen? None of that, right? Now, if somebody looks at this, he will say, well, which heart attack? What happened? Where happened? the model exactly basically follows that rules. If you don't have enough information, then you don't have enough information. Go and work on it, right? This is where we encouraging people to go ahead and add that information which we don't know about. But even here, we can say, you know what, let's still try to build a functional model based on that. And let's see what it does. What it will do, it will actually use that little bit of information of, hey, there's a heart after a heart attack. And it will go to the common knowledge and say, well, what types of heart attacks out there? What's the statistically common out there? And it will build the model based on that. So the picture all of a sudden
Wow.
looks completely different,
Wow.
right?
I have a question.
Of course.
In some of my studies, the lines that connect to the different points here, you can list as either excessive, sufficient, not sufficient, that sort of thing. Is there any
Correct.
way that these lines can go up or down to let you know which ones might be more important to look at than the others? You have so many here.
Right. Well, the heart is pretty complex thing, even though every piece of heart actually acts on the blood at the end of the day, right? But first of all, different types of functions, yes, it does take that into account, right? So for example, this is harmful,
Ah, that's what
okay?
I'm looking for.
This is harmful. Here's insufficient,
Mhm.
right? There is no excessive in this particular model, but it could be excessive as well. I think in here there was one, I believe. I don't remember. Oh no, we didn't complete. Wait. Wafer cleaning. Let's go back. Sorry about that. Oh, it kicked me out.
So in your other map, the blue was a useful, sufficient. A blue dashed is a useful, insufficient, and red is harmful.
Yeah, correct. So here you go, excessive,
Yeah.
right?
Oh, and darker blue is excessive. Yeah.
Correct. Right. So again, we can use AI and just say, you know what, do your thing. Will it bring you a really good result? No, it won't. But it can help us. It can ease the things that we do pretty good ourselves already and automate that. And then free ourselves to actually creative thinking and solve the problems that we have. Dmitry?
Will that dump that graph into a matrix as well with good and bad so you can rank your good and bad components and relationships?
You mean this?
Well, maybe what he means, like if you have an insufficient, one of them might be a little insufficient and another one would be super insufficient. So if you wanted to put the level of sufficiency.
Right. The concept of functional modeling doesn't account for how much insufficient is that. It's very objective, right? It's up to you, again, as a human being, to understand. And what does it mean, very insufficient versus, like, if you're comparing two different functions, for example, one you're saying a little bit insufficient, another one super insufficient, but they are completely different, unrelated functions. What value does it provide? That information provide? So you're
Well, if you
comparing
only had
apples
time
to
to, if
oranges,
you only
right?
had time to work on one thing, you
Right.
might work on one that's a larger insufficiency if it's a more important function.
It gives you focus on the biggest issues, the 80-20 kind of thing.
Sure, but the issue is not coming from the insufficiency. The issue is coming from from contradiction.
and how far you're from a product.
Yeah.
right? So for example, if you the fact that this is harmful function and it changes a parameter of something that we don't want to change the parameter of, it doesn't mean it's inherently bad. But if it affects the final product in a bad way, this is bad. Or, for example, as a result of the functional model, we find that there is a contradiction. We're trying to achieve function A, we can achieve it, but something else bad happens over there. That's a perfect contradiction. And this is usually where the problem coming from. These are the ones that we need to focus and not necessarily on the functions. Sorry, Dmitry, you had a question.
Yeah,
You've been with your hand up for a while.
yeah, it's okay. Yeah. So, this is cool. I can share how I was trying to use to combine functional modeling with AI like before you had this feature. I was making I have a subscription to good models, to pro models from Google. They're very helpful for me, and I was making a functional model in your platform. Then I was manually converting it into a table, like components, interactions, and then this table I provided to another AI tool, and then the analysis and the discussion started. So I wonder, is there a chance that this functional model can be exported as a CSV file or as a text file or whatever? Not as a picture, not like an image.
Oh, not as an image.
Mm-hmm.
So technically under the hood, this is exactly what happens. We are exporting it in a data structure
Mm-hmm.
in order to actually feed it to AI and everything else.
Yeah.
We're currently not exposing this functionality to the outside world, but if there is a use case, then it is definitely a possibility.
But not at the moment. I understood.
Not at the moment, no.
Okay. And what are the numbers? I found that there are some numbers in the red bulb. What are the numbers? Not here.
Here?
Yeah, I think it was in the description fields, in the description text boxes.
Description,
Yeah,
sorry.
on the right bottom corner, I saw like there was a small icon, like a bulb, and then there was a number 7 or 12. Okay, it's not here.
Hmm.
Yeah, it's not here. Anyways, I will maybe ask later when I can make a screenshot.
Okay. Okay. Yeah. Just reach out at any moment.
Okay.
Another question, Alex, is
Yes.
when you're developing the problem statement,
Mhm.
can the AI prompt you with questions for more information you need to get? Suppose you're going along and it says, well, AI says if you get this information, this will improve your models or not. I hope you
Yeah.
understand my question.
I understand. It's like the answer is yes, right? But the real answer, the longer answer, it's not as simple, not from a technological perspective, but from cognitively, what is it going to be clear for the user as well, right?
Yeah.
Because if we just ask a bunch of questions, it's great, but we need to ask the right questions. But there is probably what we're seeing as this progression of AI inside the platform is slowly we're going to improve the functionality. We're going to add additional functionality. Potentially, they're going to connect with each other. But that also includes this whole different discussion and philosophy around should AI give an answer or ask the question, right? And you hit the nail on the head in here. The AI should mostly guide and ask the questions rather than give the answers, right? AI is the one who should challenge us as the problem solvers and not just like submit to whatever suggestion it gives. And it's going to be a constantly moving and developing and evolving model for sure. But I hope it answers the question.
But what I'm thinking, for instance, is I've seen an example in decision making that says, where do I go do test wells to find oil? And one of the answers is, no, I'm not going to do any test wells. And then the next question will be, if I drill a test well, will that give me information to give me a better answer to my question? This is the kind of thing I'm thinking about.
Yeah, I think I understand.
Yeah. You know, it helps you ask questions you might not think to ask.
Yeah, right. 100%.
Okay.
Right. So again, we don't currently have that, but it's definitely something worth looking into.
Okay.
It's is the AI capable of doing that? The AI is capable of whatever we train it to do, basically. Right? It's a matter of how do we train it, how do we instruct it to do the right thing, and how do we collect the information, how do we give it back? So it's this piece of work that we need to go through to actually provide that experience. But it's definitely an amazing idea, 100%. Anything, we're at exactly at 11. If there is no more questions, I will stop the recording, if you don't mind.
I just want to add one thing that, guys, just to let you understand, we're working on our platform every day. Therefore, it is